Okay, this is the last example in this particular part of the notes. And so we've gone over converting to moles, and that's really the back and forth between moles and particles and all that. And now we're kind of finishing up here with the molecular formula, which is the last part. And then we'll have a couple more assignments. I'll have some practice problems. I'll have some homework, and then we will be through the second section. So the new thing, and this is, you might need to take some additional notes in the note packet, is this right here, this molecular formula. This is a term that you should have really had last year. And so a molecular formula, as we talked about in the notes, you got the empirical and molecular. So molecular is not simplified. So what they always do is they give you a formula, or they have you find it. In this case, they gave it to you and they said, okay, there's the empirical, there's the reduced version of this particular chemical. What is the bigger version? What is the times 2 times 3 times 4 times 5 times 6? Where's the bigger version? And so this is the empirical. If you don't have it, you have to find it, but you have it. And then over here, they're saying, okay, well, the bigger version of this, the bigger version of CH2O weighs 60. So they give you the weight of the bigger version, and you just have to figure out, well, how many times can I put the small version into 60? And that's going to give you the multiplier. So what you do is you take the formula that they give you and you say, okay, H2O. Well, how much does this weigh just by itself? And so we're going to go to our handy periodic table, and then there's carbon 12.01. Well, there's one carbon, so the carbon would account for 12.01. So there's just one of those. So let's go ahead and just add that to the hydrogen. Okay, so hydrogen right there. Oops, don't want to do that. So there's the hydrogen. It weighs 1.01. So we'll come back over here, and well, there's two of them. So we're going to go 1.01 times 2. And then last, we've got our oxygen. And our oxygen, you can go look it up. It's going to weigh 16. There's only one of those. So what you do is you figure out how much the empirical weighs. So what is the empirical weigh? So we're going to add that up on our calculator. We get our calculator out, 12.01 plus our 2.02 plus our 16. And we're going to get 30.03. So the small version weighs 30.03. Okay, so then we've found out that this one weighs about 30.03. So what are we going to do? Well, we're going to take, okay, we know that the small version weighs 30. We know the big version weighs 60. It's really easy at this point. You take how much the big version weighs, 60.0 grams per mole. So it's how much it weighs. And we divide it by the small version, 30.03. Not a very good looking G there. Grams per mole. These cancel. It's going to give you a number. Well, 60 divided by 30 is about 2. That's going to be our multiplier. So this becomes a multiplier. So you're looking for a multiplier so that you can multiply everything in there by that value. So what we're going to do is we're going to take CH2O. We're going to multiply everything in there by 2. And that's going to give us C. Well, 2 times 1 is 2. And H, 2 times 2 is 4. And O. And there we go. That is our answer. That is our molecular formula. So what is that? that is something that is not simplified. So molecular is something that's not simplified. Well, this is obviously not simplified because those are 2's and 4's. So I could divide this by 2, divide this by 2, divide this by 2, and it would become the empirical. But they wanted the molecular, so we have created a form. So just to kind of sum up, you are given or have to find the empirical. Once you have the small formula, you figure out how much it weighs. And that's what we did here. Figure out how much it weighs. Then you compare how much the small one weighs to how much the mystery one weighs. Well, the mystery one weighs 60. Then you divide them like we did here. 60 divided by 30 gives us our multiplier of 2. And then you just multiply your original formula or your empirical by 2. So molecular is usually pretty straightforward if they give you a problem where it's easy